Now here's another theorem that touches on the quadrilateral. And quadrilateral is a shape that has four sides. And when we see the word or prefix quad, it should remind you of anything that has to do with four sides or anything that has to do with four. And examples of quadrilateral shapes are square, rectangle, trapezium, and parallelogram. So a cyclic quadrilateral shape is a shape that fits perfectly in a circle, which also means the vertices touch perfectly on the circle. So if that's the case, the opposite angles are supplementary. And since they're supplementary, when you add them, they sum up to 180 degrees. So over here we have a circle as well as a quadrilateral shape with points A, B, C, and D. And remember, quad should remind you of these four sides. And it's a cyclic quadrilateral shape because point A touches the circumference, point B touches the circumference, point C touches the circumference, as well as point D, it touches the circumference. So the conclusion we can make is that angle A plus angle C should sum up to 180 degrees, and the reason is opposite angles of a cyclic quad. And it's quite clear that there's a relationship between angle B and angle D, in a way that if they gave us 60 degrees angle D, then we'd be able to get angle B, since angle B plus D should total 180 degrees. So angle B would be 120 degrees, and this is when you substitute that D into 60 degrees and transpose it to the other side. It becomes negative. So it's going to be 180 minus 60, and then we get our angle for angle B, which is 120 degrees. And the reason would be opposite angles of a cyclic quad. But the theorem does not exist if one of the 4 points, A or B or C or D, does not touch the circumference. And that would clearly mean it's not a cyclic quad.